So next we move to the algebra of functions. So here we are dealing with real valued functions. So that means we are just looking at A, B, C, D. These are all subsets of real values. So they are real valued functions of a real variable, of one real variable. So we define a few things here. So first definition is that of addition. So if we have two functions, f which has domain A and range B, and g which has domain C and range D, the addition of these two functions f plus g has domain A intersection C in some range E, and it is defined as f of f plus g of x is fx plus gx. Okay, so similarly, when you are multiplying, so we call that f dot g. So f dot g is again defined on the intersection of A and C, and it is defined as fx into gx. Similarly, f minus g. We have to be a little more careful when we are looking at divisions. So fx by gx. And when gx is 0, because division by 0 is undefined in mathematics, so therefore we have to reduce that set from the domain. So the domain of f by g is slightly lesser than the domain of other f plus g or f dot g or f minus g. And it is the domain is A intersection C minus t, where t is the set where we have g is equal to. The composition of a function is a very powerful idea. So what it says is that your f is a function from whose domain is A, range is B. G is defined on B and the range is C. Then the g composed with f is a new function whose domain is A and the range is C. And we define the g composed with f, which we generally read as GOF. So GOF as of x as, you first apply f and then apply g. So it is g of fx. So that's called the composition of functions. One way of viewing functions is to think of this as a machine where you give an input x and what you get out fx. So for every input f, which comes from the set A, you get an output fx, which is in the set B. Now, in composition of functions, we have two such machines. So we have x, then this x goes into the function f and outputs fx, and then g picks up this fx and outputs, which we write as g composed with f and x. So I can think of this whole thing as the function g composed with. So fx is equal to x square and gx is equal to 1 by x square plus 1. Then composing this, you get 1 by x to the power 4 plus 1. Similarly, using e power x plus 1 and x square plus 1, you get. So you can get much more complicated functions by composing simple functions. The neural networks, the artificial neural networks, which powers a lot of our life today, what it does is it uses simple functions and then compose these functions in a certain ways so that it is able to approximate a large variety of functions coming in different walks of life.